Okay, so hi everybody, Martin speaking. Today I will show you how to construct a steel bracket like this in solid edge as multi-body object. Uh, you can model it in a different ways, like in assembly, just display it, this one, this profile as an okay, but today I will show you how to quickly make it and model it in part environment with multi-body object. Okay, so I don't have any other dimension. I have just this side view, and I know this is the concrete slab, and we need to connect it with bolts and with some kind of anchoring system to the concrete, and it will hold the window elements. Okay, so this green one is this bracket, is this steel bracket. Let's measure it. It has approximately 660 millimeters. So okay, so let's do it. If I want to model it in a synchronous technology, there is some problem with blocks. This one is a block. This one is block with this name. If I just copy it and paste it as a sketch, nothing happened because blocks are not supported as a pasted object in synchronous mode. That's why I need to go to the ordered mode, make a sketch, and then you can paste it and position it like this, for example. And now you have a sketch in an ordered mode, and you can easily then convert it to the synchronous. And now you have a block reference geometry in a synchronous mode. Okay, so just delete it because I want to do it that way. I open the block, and here's the geometry exploded. Just when this anchoring system is in block, but at the moment I don't need it. I will just need these green outlines. Okay, let me just select it like this. Okay, okay, I just selected all, then unselect the anchoring system, unselect this one here, and okay, I will keep this. Copy it, Ctrl C, then paste it in a synchronous mode, and for example I'm blocking the plane with F3, pasting it. Okay, so we need to position it for it's better when things starting at the zero coordinates in some reasonable point. For me will be okay, that point is reasonable because it's the edge of the concrete slab. Okay, so I'm missing some regions, This line here should be connected with here. This one, okay, connected, and I'm missing a line here. Okay, so I have regions, and now I can construct. Okay, so this one will go. I think this bracket will be symmetrical. Okay, so with a shift, you can easily switch between symmetrical, extrude, or just one-sided. I don't know how bright will be. The brightness will be, I don't know, I guess 400 maybe. Just for now, it's 400, we can easily change it later. Okay, so this is our first body. Sorry, my Czech environment. But I think you can you can easily work even if you have an English environment. With F2 I can rename it. This will be top plate. Okay, so let's just construct this front plate. I need to reuse sketches. Okay, so if I now make extrusion, it will be the same object. I don't want it. Just Ctrl Z. Let's make a new object, new part. This is top plate. This will be front plate. Okay, so and just extrude it like this. Okay, top plate, front plate. Okay, let's again reuse sketches, and now we will construct these profiles. I think this is rectangular hollow section. It's 80 millimeters. I think it will be squared. It's 80 by 80, and the wall thickness is 5 millimeters. Okay, so let's just quickly construct it. Create a new body. Profile 01. Let's just extrude with a chain selection. 80 millimeters. Okay, perfect. Now we can make round corners or these edges. It's 8 millimeters minus 5 millimeters the wall thickness. The inside diameter will be radius. Sorry, will be 3 millimeters. That's okay. That's reasonable. Okay, so like this, and then thin wall. Remove this face and this one. Okay, and here we have inside the nice radius, 3 millimeters, and our profile is 80 by 80. Yes. 80 by 80. It's 5 millimeters, the wall thickness. Okay, let's just recolor it a bit. Blue light is okay for this one, and the plates, okay, let's make them orange light. This one. Okay, so we have one profile, we need two more. Profile 1, just select it, right view, position this cursor here, and just with the Control pressed, just click the the arrow and make a copy. Make a copy of the object. It's really here created. Let's just copy the name, paste it, it will be profile 02. Okay, we need to shorten it, but not this one. So like this. We can recolor it. Light. Override styles. Okay, we have second one and we need the third one like this. So just make a copy of this one. Okay, we can hide the sketches for now. So this one new, it's a profile 03. We need to rotate it minus 90. Let's take a look from the right side, reposition and move right here and move it up like this. Okay, shorten it. There are more ways to shorten it. This is the easiest. Just grab the face and shorten it like this, or you can make it like select the face, select the coplanarity and make it coplanar with this one. There are always hundreds ways how to model something. Okay, so far so good. We have some kind of rip here. Okay, we can make another body. This will be rib 01. Okay, we can make it from here, I don't know, 10 millimeters. Let's just hide some objects, grab this face and slide it over till here. Okay, very nice. But this body intersects with this profile, so for these profiles we need to have a cutout here. We can easily make it like this. Select the profile, or nothing selected. Select these bodies, like this one, and this is the result. Oops. So now if I turn off this rib, it's not the rope, it should be rib. Here's cutout, nicely done, easily. Okay, let's color the rib with the orange color. Okay, override styles, yes, and this profile with blue color. Okay, perfect. So far so good. We should save it. We should save it somewhere. In my case here, we'll bracket 001. Okay, and now we can open it in assembly, because in part environment just the active body is shaded, others are transparent. So if I want to show someone, or if I want to view this one shaded or all shaded, I need to open it in assembly. Don't close the actual document because I want to continue working on it. I can later close it, but for now I just want to stay open. And here we have it with assembly in assembly environment, fully shaded. Okay, so what we need now, some openings or holes for these connection components for this anchoring system. Okay, so we can easily make it. We need one in the top plate. Okay, let's measure what's the size of this screw. It's 16 millimeters. Okay, and in most cases these concrete slabs are made in tolerances. It's plus minus 25 millimeters, so it's in this direction and also in this direction. So if I make the very narrow hole, I can make a conflict with already built-in or built-in connection system, anchoring system, which could be in 25 millimeters in this way or in that way. So that's why we need to have a bigger hole, and then this plate with a narrow hole for the screw, and then this plate could be welded to the plate, to the base plate. Okay, can you imagine it? Maybe no. Okay, let's model it to imagine it more. Okay, so in the top plate we need holes. So lock the plane with the F3. It's locked. If I click here, I can unlock it, and then I can lock it with F3 or unlock it with F3 again. So with the plane locked, I place two holes, one and the second one. They should be mirrored according to this plane. It's reasonable, but for now they are not. This one is 78. This one is 88 millimeters. Okay, come on. So if I now grab this hole and move it, it moves independently. I want to move it like they are mirrored. So of course there's more ways to do it. If I have these dimensions here, I can easily write 80 here and 80 for this one. And since now they have a mirror constraint, okay, so if I move this, they move together. Okay, Or let's go back a few steps, or I can select this one, choose mirror constraints, select it, select, come on, select this hole and the plane. Oh, come on, doesn't work. Let's again. Once again. Okay, selected hole, then this hole, wait, this one, confirm, and now select the plane. Okay, and since now they are they have a mirror constraint. Okay, so if I change this to say 100, change also together. Okay, so for now 5 millimeters is too small. I need 50. 50 is okay. And okay, let's make this dimension. It's 100. Okay, 100 is okay. Let's check this one if it's if it was sketched properly. Okay, let's correct it. 375. Okay, so we forget to lock this dimension. We can lock it. It changed its color to red. Now correct it to 100, and now if I change this one, for example 500, it stays with it. It was 375. Okay, so we have two holes like this, and let's go for this front plate. I have locked this plane, so unlock it, lock the front one, again one, second one. Let's make quick dimensions. It will be 85, I don't know, this one also 85. The size again 50, and the offset from the bottom will be 85, maybe. Let's check it. Offset from 85, okay. And here's 96. Okay, 85, 96. Okay, let's make it 85, and this one 96. Okay, 85, 85. This one is 100. Okay, so far so good. We have holes, we have plates, ribs, profiles, and this one will be welded assembly. There will be some welding here, 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 and there. Okay, so this is assembly environment, and let's create these plates. This one. It's 120 millimeters, 7.4. Okay, let's make it 8. 8 and 120. And this will be square. Okay, so let's create it in assembly environment. It will be new part. This part is just one multibody. and this plate will be new part added in assembly environment. So I need to first save it. Okay, save it. It will be bracket, but not part, but assembly. Okay, and now I can make a new part. I select it graphically to set the origin. Press G to make it identical with the global axis. Okay, so I want the center of the new part be here in this hole. Okay, it will be, the material will be S235. It's okay, just press OK, and name it. It will be plate 01. Okay, let's just rename it. No, let's create a new part. 02. Okay, and from now we can easily create a body. It will be 120, 120. This is okay, and just one-sided. Press Shift, Shift, one-sided, and it was 7.4, and let's say it will be 8 millimeters. Okay, and let's create the hole. It will be 17. It needs to be more precise. Okay, change the color to the orange. Okay, perfect. Now we have to add this anchoring system. This special anchoring system which can be built in a concrete slab. There are a lot of suppliers of this. Concretely, this one is from the company Halfen. Okay, so I have this anchoring system here. Let's grab it to the assembly. Okay, it looks like this. Okay, so let's position it, but first I need to position this plate because it has no constraints, nothing. It can float everywhere. Okay, so position it like this. This one will locked to the circle, and this plane to that plane. Okay, so it's fully positioned. Now let's position this one. Okay, this plane with this one. Now I want to be in the center, because these anchoring systems are made in certain dimensions. For example, this one is 300 millimeters bright, long, and in this range I can move these bolts. If I need this, if I want this bracket to be larger, I need to order another type of this anchoring system with a larger profile, C profile. Okay, so let's check it if our holes offset matches with the one I have already set here. It's 160. Okay, so let's position it in the position for in the correct position with holes. So I have this constraint, this one, center one, and I need to adjust the height. I now know that I cannot center this one with that hole because it's 160 into 230. So I can easily position it like this with connect option. This plane, it's in the middle with the center of these holes. Okay, so if I turn off the plate, I can see now it's in the middle, and now I need to adjust the position of the bolts to the holes, or adjust the bright of this bracket, because it was just guess that it will be 400. It could be less, or we can simply adjust these bolts, but I will be too close to the edge if I adjust the bolts to 230. So we can easily adjust the bracket. Okay, let's close it now, and let's edit it in assembly mode. Just edit, front view, grab one side. We now know that it's mirrored, so if I move one side, the other side goes with it, and just make it smaller. Okay, now it is 330, it's 160, and this plate is here. Okay, so if you make this plate visible through, we can see that if some tolerances will be here, we can simulate it, like grab it like this, and for example it should go here. Now we see the collision with the profile. We can either move this hole in vertical direction, lower it, and this should be okay, but if we have this situation, we have just few millimeters here, I can say 5. Okay, so we can go 5 millimeters down with this with the hole, and let's see what it will look like. Okay, so let's grab the hole. Let's turn it off. Oh, we can switch. We need to switch our cursor with a control and space. Control and space. You can cycle between object selection mode and face selection mode. So if you have a part modeled in synchronous mode, you can select it like this in assembly environment and transform it. And when you are in an object mode, you can select it just like other objects, like ordered object, and position it with the constraints. Okay, so we need to change this one to face mode, position it, grab it, move it 5 millimeters down. Okay, let's show this bracket system. It goes directly with it because it has these constraints. Okay. Now, if I grab this one and look at it in this position, it's close, but it's okay. We can weld it here in these 3 places. It don't need to be welded all around this one when it's positioned. It's enough to weld it like here, here, or maybe here. It depends on the position. Okay, so let's position this anchoring system also here on the top. Now we have these constraints here. We can reuse it when positioning here on the top. How to do this? Just click the assembly with the with the constraints. Here, this nice button. Remember the constraints. Here are these three guys. So remember these 3. You can remove some, but in this case we use it like this. Change set OK. And now if I copy it and paste it, it will automatically want it from me these constraints. So this one was first, it's here. This one was with this plane, and this connect was with these holes. Okay. These holes are in other position. Let's quickly correct it. Grab the hole, snap the center, and we have it like this. Okay, quickly save it. Now, what do we need now? We need to fasten it. Okay, so these are the standard elements. I have the library of the standard elements. Here are the connection components, washer, it will be standard washer, This bracket will be outside, but let's look at the closed view. It goes outside, but it's completely insulated and covered with some cladding. So I think the material for this one will be standard steel S235 with zinc coating. That's why I choose also zinced connection components. Okay. So 200 HV zinced. This bolt is M16, so it's this one 16. Let's grab it, position like this. Okay. So as you can see, this washer has already remembered these constraints. So do the nut. Let's find nuts, hexagonal nuts. Okay, so it's 16. So if I just drag and drop to the scene, I already prompt to choose the cylinder, and then this side will connect with this one. Okay, perfect. Okay, so let's just make an array or copy them also to the other positions. So we need to copy this plate, this washer, and this nut. And we can also make it different ways, but I choose the duplicate. Let's select as a base object this bolt and duplicate it to this one, that one, and that one here. Okay, so, and now we can see here some intersection. That's why this plate is 15 millimeters. This one is 20. Okay, so the difference is this 5 millimeters. 5 millimeters is difference, so it's dipped into. We can correct it like I don't know. We can separate the array, the duplicated components. Just grab this one and correct it like this. It's the fastest way. Or there are many other ways like to do it. But for now it's just okay. It's just okay. So we have a bracket, we have anchoring system, we have a fastening system here. Let's just quickly model the concrete slab. It looks like this. Okay, so we can easily grab these lines. I don't need that one. Just copy it, go to the bracket. Now create new part in place. In this case, I choose the same as the assembly origin. Okay, it's okay. I choose concrete. Let's concrete in our language and create. Okay, so this will be concrete slab. In this case, I can just paste it in synchronous environment because it was not a block, just the geometry lines. And in this case, I always try to make these lines, these copied lines from other drawings, vertical or horizontal, if they should be vertical or horizontal. Okay, because sometimes they are not leveled properly. So for sure I connect the vertices, the ends. Oh, come on, why it is not connecting? If I make it like this, okay, and let's connect here, this one, and close it here. So position it here and move it. This is 15 millimeters in X direction, and in Y direction it will be 0. Okay, so now I have a base geometry. Let's extrude it both sides like this. It's okay. Close. So we have the slab, we have the bracket, and now let's separate these guys. Okay, so for this operation we need to open it like this, like a separate part, not just open it in assembly for some retouching. This must be opened as a separate part. Okay, now we need to go to the multibody options and publicate bodies. Okay, the name of the parts will be taken from these names. So if you want to organize them better, so just rename it. You can make it also here if you want to publicate, and here we can name it like a bracket 01 001. Okay, just select it, copy and paste it also to others. Okay, bracket 001 ISM. Okay, that's okay. Now save the parts. It takes a while, and now we can open them by right clicking and opening the assembly, and now we can see that every part is separated But if I open it, it is a part copy. It is a part copy of this one, this bracket 001 part, this multibody part. Okay. So if I change something in the original file, in this one, so if I move these holes, it will automatically update here. But for now, we are not going to make it. Okay. Just close this one, save it. Okay, so now we have this part, this assembly, welded assembly. It will be welded. We can make it like this. There's welding. Mark this one as a weldment. Okay, and now we can add some welds. For example, we can weld this one to this one. We can try it. Okay, this weld, the settings are okay. So choose one plate. This is the base plate, and then let's choose faces which should connect to this one. Right click, preview, and here is our weld, 4mm weld. I can easily change it. If I want a bigger weld, for example 6, it's significantly bigger. Okay, it's the real weld. So we can easily weld it together, make some routing, some chamfering, shortening here, cutting of this edge to properly weld it. These two guys will be welded like this, or maybe this edge will be chamfered like this. Yes. Because here I need this corner because of the slab. No? Here cannot be weld like this. So it will be chamfered here and welded from this side, and that's why this one needs to be chamfered also, this orange guy. Okay, so let's do it quickly. This one, here's chamfer. 1mm is too small. Let's chamfer it 10mm. It's okay. Now it's perfect for welding. It's prepared for welding, at least this one. We can also prepare this one for welding. Let's chamfer this one, and for now it's 15mm. For the weldment like this, I need both sides to be chamfered. 5, maybe 6mm. It looks good. Okay. So here are also this edge is prepared for welding, and we can weld it later on. Okay. So, but in this assembly we have still the part we need to replace it. Just right click, next, replace, right click and find this bracket, open it, and we have replaced assembly here. Okay, so let's hide unnecessary elements. Okay, this one could be transparent, for example white clear. Okay, we can see the anchoring elements here. We have a bracket, we have profiles. Okay, so this is all for now, and in next video we can take a look at naming, making some custom properties of these parts, making a drawing with we can play with some settings, we can play with some visual settings. Okay, so we can quickly show what kind of drawings this can be. For example, this one, just quickly copy it, make a front view, or better left view, or right view is better. It is consistent with these views here and in this drawing, so we can easily create a top view. Isometric is here. It's a little boring. We can make it less boring, like this. Or if we don't want to shade this concrete slab, we can go to settings, find the concrete slab and mark it as a reference. When it's marked as a reference, it will be not shaded. Okay, so, and the visible style, it's normal. The style of the edges, it's normal. Okay, and now if I regenerate it, the slab is not shaded, but the bracket is shaded. Okay, but this one will be the part of the next video. Okay, so thank you for staying with me so far, and bye.